Here's another example of a linear equation in one variable. It's an equation. We know that because it has an equal sign. It's saying that this expression will be equal to 28 when we find the right value to put in place of x. And that's our job, to find that value of x that will do that. That's what's involved in solving an equation. You're always looking for the value that you can put in place of the variable that will make the value of the left expression equal the value of the right expression. The exponents on the variable are 1. That's what makes it linear. And there is only one variable. So indeed, this fits the characteristics of our linear equation in one variable. We should then use our procedure that we have for solving that kind of problem. Our first step in our procedure to get us from problem to solution is fractions. Remember, frantic partiers, excitedly open icy cokes, frantic for fractions. Are there any fractions? No, so we don't have to worry about that step. We're automatically up at the step of partiers, parentheses. Our equation has parentheses, so we're going to use the distributive property to remove those parentheses. Multiplying minus 2 times each of those terms gives us minus 8x. Now watch this. This is where it's easy to make a mistake. Minus 2 times minus 6 makes plus 12. Very easy to make a mistake at that point. Now, expressions. The right-hand expression, there's only one term, so there's no combining of like terms we can perform there. But we can simplify the left-hand expression by combining the two like variable terms. 12x minus 8x gives us 4x. Fractions, parentheses, expressions, one variable. Do we only have one variable term? Yes. So we're already at that step. We can go on to the next one. We now want to isolate that variable term. To isolate it, I have to get rid of this plus 12. I would do that by subtracting 12 so that that disappears into 0. But remember, an equation is a balance. If you take something away from one side, you have to take the same quantity away from the other side to maintain that balance. And we have 4x equals 16. And our last step is coefficient. We want a coefficient of 1. Right now, this variable term has a coefficient of 4. The way we make that coefficient into 1 is we divide by whatever the coefficient is that's there. Because 4 divided by 4 gives us positive 1. And that's the coefficient we want for our variable when we're solving an equation such as this. But if we divide one side of the equation by a quantity, we have to divide the other side by the same quantity to maintain that balance of our equation. And 16 divided by 4 is 4. So if we were to take 4 and put it in place of x, we would find that the left-hand expression would become 28. Let's see if that's really true. 12 times 4, well, that's going to be 48, isn't it? When we put 4 in place of x. Putting 4 in place of x here, 4 times 4 is 16. 16 minus 6 is 10. Minus 2 times 10, that's going to be minus 20. And sure enough, 48 minus 20 indeed is 28. We know we have found the correct solution because it made the left-hand expression have the same value as the right-hand expression in this equation.